गुड मॉर्निंग एवरीवन। आज की क्लास में हम लोग बात करेंगे कोऑर्डिनेशन कॉम्प्लेक्स का सबसे पहला थ्योरी एंड दैट इज़ वर्नर्स कोऑर्डिनेशन थ्योरी। ये वर्नर्स कोऑर्डिनेशन थ्योरी में बताया गया कि किसी भी कोऑर्डिनेशन कॉम्प्लेक्स का दो डिफरेंट टाइप्स का वैलेंसीज होते हैं। द फर्स्ट वन इज़ कॉल्ड प्राइमरी वैलेंसी and second one is secondary valency. Now, what are the characteristics of primary and secondary valency? First of all, primary valency satisfied by the negatively charged ion. जितने भी negatively charged ions होंगे दिए हुए complex में, that will gives the idea about primary valency. Second, primary valency is non-directional. It can be represented in the structures of complex in any direction. It is represented by dotted line. Primary valency को हमेशा dotted line से represent किया जाता है. Primary valency gives the idea about ionization of the complex. किस प्रकार से complex आयन में ब्रेक करता है when it get dissolved in an aqueous medium. Oxidation state of the metal atom. By knowing the primary valency, we can identify the oxidation state of the metal atom present in a given coordination complex. Sometimes negatively charged ion satisfy both primary and secondary valency. कभी कभी यही नेगेटिवली चार्ज आयन प्राइमरी वैलेंसी को भी सेटिस्फाई करता है और सेकेंडरी वैलेंसी को भी सेटिस्फाई करता है. नाउ द नेक्स्ट पार्ट, secondary valency. What is secondary valency? It is simply defined as the number of donor sites of the ligand attached to the central metal atom in a given coordination complex is said to be as secondary valency. ligand के जितने donor sites attached होंगे central metal atom के साथ, that will gives the idea about secondary valency. Secondary valency is directional. Secondary valency is directional means secondary valency always represented in a proper orientation. It gives the idea about structure of the complex. By the help of secondary valency, we can find out the structure of the complex. Represented by solid line. Secondary valency is always represented by solid line. So these are the characteristics of primary and secondary valency. So if we conclude Werner's coordination theory in a very simple way, then we can say that according to this theory, it has been stated that in any coordination complex, there are two types of valencies, one of which is called primary valency and the other one is secondary valency. Each of these valencies have certain characteristics by which we can find out lot of information about the given complex. Now, Werner's theory can be implemented in this particular formula. This is Werner's coordination formula. And what is it? COCl3.6NH3. So it's negatively charged ion, chlorine And how many chlorine atoms are there? There are 3 chlorine atoms. So 3Cl minus means primary valency is 3. Got it? Now, primary valency gives the idea about oxidation state of the central metal atom. Cobalt is central metal atom. In this complex, the oxidation state of cobalt is +3 because primary valency is 3. So this is Werner's formula, and it is very important to note that Werner's coordination theory is applicable only in case of octahedral complex, or we can say that the Werner's theory is only applicable for the coordination complexes having coordination number 6 and shows the octahedral structure. So we can say that it is the limitation or demerits of Werner's coordination theory. So first of all, just note it down and then we'll discuss Werner's formula and how we can write the geometry of the complex by using Werner's formula. Now see this COCl3 dot 6NH3. This is Werner's formula. This is Werner's formula. Cl minus, so its primary valency is 3. Oxidation state of cobalt is +3, and ligands, ammonia is ligand and nitrogen atom consists one unshared pair of electrons, so it is donor atom. How many donor atoms are there? 6. So its coordination number will be 6 and geometry will be octahedral. So we can represent secondary valency gives the idea about geometry of the complex. And what is secondary valency? Number of donor sites of ligand attached to the central metal atom. So we have structure like this, very simple. S3 and these are secondary valency, so solid lines are used. Now 3 chlorine showing primary valency represented by dotted line. So I hope that it is easily understandable for all of you. Now if we consider another example, COCl3 dot 5NH3. COCl3 dot 5NH3. NH3 represents secondary valency, and what is the coordination number? That is 5, and Werner's formula is applicable only for the octahedral complex having coordination number 6. So 1 chlorine Cl minus ion satisfying both primary and secondary valency. So we have structure like this. First NH3, NH3, and this is Cl. As we have mentioned earlier, that sometime Cl minus ion or negatively charged ion satisfying both primary and secondary valency. 2-chlorine simply represent by dotted line, and the third chlorine showing the both primary and secondary valency. This is the structure. And the last one, CuCl3 dot 4NH3. This can be written like this. First octahedral structure, 2-chlorine satisfying both primary and secondary valency. So we have dotted line as well as the solid line, and 4NH3 can be represented like this, and this is 1-chlorine. So we have discussed Werner's formula and how the Werner's formula is used in the structure determination. very इम्पॉर्टेंट टॉपिक, तो आप लोग इसको बहुत अच्छे से करना है। और इसी वर्नर्स फार्मूला को अगर मॉडर्न फार्मूला में चेंज करें तो CONH3 होल 6 Cl3, इसका हो जाएगा CONH3 होल 5 Cl, और यहाँ Cl2, और लास्ट का CONH3 होल 4 Cl2 Cl. So Werner's formula is transformed into modern coordination formula. Modern coordination formula. तो जब भी वर्नर्स कोऑर्डिनेशन थ्योरी पूछा जाता है, इन वर्नर्स फार्मूला को कैसे रिप्रेजेंट करते हैं वो दिखाना है। वर्नर्स फार्मूला को मॉडर्न कोऑर्डिनेशन फार्मूला में कैसे चेंज करते हैं ये करना है, और सिंपली बताना है कि अकॉर्डिंग टू वर्नर्स द कोऑर्डिनेशन कॉम्प्लेक्सेस हैव 2 types of valencies, primary and secondary valencies. The negatively charged ion responsible for primary valency, and the electron rich species which are known as ligand responsible for secondary valency. So I hope that this particular topic is very much clear to all of you. If you like this video lecture, then do not forget to subscribe this particular YouTube channel for better understanding of chemistry. Thank you. Goodbye.